Lucas. Oh, there he is. Hi, Lucas. There's Felipe.
Hi, I'm here.
Hey, guys.
Oh,
We're getting people hopping into the room here. Welcome, everyone. Welcome. hope the conference is going well for everyone so far as they're jumping in. We'll give this a few minutes and let people hop in. You know, I'd really be excited if we were using SaltStack to configure Fortnite instead, but hey, you know, this is great too.
We just got permission to mention the name of our client in the presentation, so that's exciting.
Great, fantastic.
Yes.
Okay. Just got a few minutes here, and then we'll get started. Going to get a lot of people hopping into the chat here in the next few minutes, so we'll give everybody a little bit of time.
Now go ahead and open the slideshow.
There you go. Okay. Yuri, welcome to the session. Glad you're here. Felipe, welcome to the session. Thanks for coming.
Okay. I will start.
Not quite yet. Let's give it another minute or so.
Oh, okay. Sorry.
Hi, Danielle. Welcome to the session. Glad you're here. Raphael, welcome. Give everybody a few minutes. Excuse me. Alessandro, hey, how you doing? Welcome.
Oh,
glad you're here. Few more minutes, guys. We're going to give people a few minutes to jump from one session to the next and hop in here, and we'll be good to go. How's Brazil today?
it's hot here.
You're good? Is it?
Yeah.
It's very cold where I'm at, so it's I'm jealous.
Yeah, you guys are in the middle of autumn, I think.
Yeah. Yep. Hey, Ricardo, welcome to the session. Glad you're here. Alessandro, are you in Brazil as well, Alessandro?
Yeah.
Ah, okay. So you've got Brazil is representing. Edison, welcome. Hey, Jacob, welcome. All right, people are filing in here. Let's. I think we're about ready to get started. Hey, everybody. Let's. Yeah, Gabriel's hopping in. I guess we can go ahead and get started as people are filing in here. Welcome to our session called "Using SaltStack to Configure Fortinet Firewalls at Scale." Very excited to have these two guys in the session here with me. These guys know everything. They've forgotten more about how to do this than I will ever know. They're live and direct from beautiful Brazil. Very excited to have them here. They're from SSYS. The company is called SSYS, SSYS. They're an IT consulting firm. We have Felipe Morais, and we also have Lucas Sanches. Why don't you wave hi, guys? See you there in the virtual area. So, excuse me, as we go through the session here, what we're going to do is we'll have a 10-minute Q&A at the end of the session. So, if you have any questions, you're more than welcome to write them in the chat, or you can hit the share audio and video button. It's a green button at the top of the screen there. And if you'd like to do that, it'll let me know that you have a question, and we can go ahead and I'll share that with you as well. But I would ask that you wait, as English is not Felipe and Lucas's first language. We're going to have them just go through their presentation, and then we'll wait and hold questions till the end. You guys okay with that, Felipe and Lucas? You guys all right with that?
Sure. That's perfect.
Excellent. Okay. All right. Well, from SysYS, ladies and gentlemen, this is Felipe and Lucas. Thank you so much for joining us.
Thank you all for watching.
Okay. We are going to introduce our use of Salt to configure Fortinet firewalls. In this case, we are responsible for automating the configuration of the client's firewall roles and integrating the solution with ITSM tools. That's it. We needed to link ServiceNow and network management on Fortinet. Well, let me explain about Fortinet. Fortinet is a company that develops commercial cybersecurity solutions such as firewall, intrusion prevention, VPN, proxy, and others. Fortinet develops software and hardware solution that's able to see which applications are using the network. This enables the administrator to make a decision with whether to allow or deny the traffic based on this information. My opinion, it's a good tool to administrate IoT devices in enterprise context. Fortinet is also a family firewall named FortiGate. FortiGate is a Fortinet line of firewall that, among other things, can provide access control for machines inside the network to the client servers. FortiGate has some features like antivirus scanners, which can detect virus and another payload used to infect machines. Application control, which can block the use of some applications by blocking the ports they use for communication, if application doesn't use extended ports to communicate. Already, web filtering can help stop infections from malware sites. Those are the features we get with their solution. So let's go over challenges. The main issue is faced was the need to automate the process of configuring Fortinet firewall policies for their FortiGate device. Another challenge is integrated this automation with a change management system. Also, to need to guarantee that their FortiGates always keep their configuration in sync with various requirements, if you need to manually check them one by one, especially when the policies could be manually changed directly into the firewall. The company already had ITSM tools, but in the end, the process has still been done manually. In this case, it was complicated to guarantee which was done right. We need to find a solution that allow the configuration to apply it to the devices once approved in the ITSM tools that are using ServiceNow, and we needed to be automated. On top of that, our clients Via Varejo need to manage more than 1,000 FortiGate devices and more than 55,000 machines. So this solution needed to able to handle such amount and be scalable. But why the machines is important? In this case, these machines can have different operating modes or profiles. This different profile demands different firewall policies and a little improving change. Okay, that's the challenge we are presenting. Okay, go back to Fortinet. Fortinet also provides a solution named the Fort Manager, which centralizes the configuration of the multiple FortiGate firewalls. But due to the number of the stores our client has, among with the new ones about to open, it's the requirement do a more expensive license to be able to use Fort Manager in all their FortiGate firewalls. It's a big problem. Uh, FortiGate, in this case, a Fort Manager, it's a one alternative we considered that could possible solve to our client issues. But the license cost makes this alternative impracticable for our client. So we tried another approach and we developed ours on customized solution using Salt and another open source tools. Uh, to connect all those things, I will briefly go a trophy that we had already implemented for this client. We had already implemented Salt in their environment, and there are also a custom Linux operation system. If all the tools used by the client, include the Salt agent to guarantee that the machines keep their original configuration as needed by the client. Well, for each existing store, there is at a last one FortiGate device responsible for managing all the machines in the store, in this case, minions. Here you can see a layout of how the devices are set up in Via Varejo environment. As I said before, Salt has currently handling more than 55,000 machines, and to be compliant with PCI standards. We use FortiGate for external access, but the local network we use IP tables roles in the roles because FortiGate cannot control this level of communication, and we use the Salt agent to guarantee these roles stay applied. These minions can have different operation modes that can be selected by a technician through and installation script when set up the machine. Different profile demands different policies to determine which server to minions can or cannot access. Also, the policies may vary due to different jurisdiction between Brazilian states and give these requirements. We needed to store firewall policies separated by profile and on a store-by-store level. And now Lucas continue our presentation.
I saw a bunch of people joining the presentation. Welcome, everyone. So Felipe told you about Via Varejo, our client's environment. And now I will cover the implementation details of our solution. So first, let's go over some Salt concepts first. I will assume everyone here is familiar with the basics of how Salt and states work. If you're not, they have an excellent documentation with tutorials and examples. They also do trainings and certification. I highly suggest you take a look at the website, saltstack.com. Go and check it out. They have everything you need there. But on top of these basics, we also took advantage of three major components within Salt. You use reactors, which are used to trigger trigger actions in response to an event being fired in Salt's event bus. We also used orchestrations, which simply put are basically states that run in the master. And we also used external pillars to be able to read pillar data from a database. So I will be going over each of these concepts just to give you a brief overview of them in case you are not already familiar with them. So Salt has an underlying event bus. It's basically just a pool of events that can be listened to, and events can be published to it. And the Reactor system is basically an observer that listens to this event bus and triggers special Reactor states every time a specific event is published. These events can carry useful data to identify the event, and they can be published by a minion, but they also can be published in some cases by the master for some internal events. For our solution, we don't care about those. We only care about publishing events by from the minion. So here's an schematic to represent how reactors work. Starting here at the bottom, you have minions running states, and these states can publish events to the event bus. Then you have the reactor system listening to this event bus, and when a specific event appears on the event bus, the reactor starts the reactor states associated with that type of event. These states can then execute runners in the Salt master, which can then send commands back to run states in the minions if needed. Also, this part is optional. You can have, for example, the master just being used to configure external resources like databases or firewalls in your case. So sending commands back to the minions is completely optional. And also note that the event bus and the reactor all run within the master environment. It's isolated from the minions. Okay, so let's talk a bit about orchestrations. Orchestrations, they are like states, except that they run on the master instead of running on a minion. That's a very simplified way to put it, but that's basically what they're used for. Orchestrations are very useful when you need to have a globalized view of the system. Let me give you an example. Suppose you need to configure multiple minions at once in a specific order. So you could use an orchestration to sort the order of minions you need to configure, and then configure them on one by one from the master. They are also useful to configure external resources like load balancers or, like in our case, firewalls. And one of the advantage of running states on the master is that all sensitive data, such as databases, passwords, credentials, secrets, they are all stored in the master, and they are never sent to a minion. They stay within the orchestration. So in your case, only the master needs to access the database. So the minions don't have access to the database. And the orchestration runner is the runner responsible for running these orchestration states on the master. So just to give you an example, this is what the orchestration looks like in your case. So we have the orchestration runner running on the master to configure external resources such as databases, firewalls, load balancers. And notice how in this image we don't involve minions. Everything is run by the master. You can, however, use an orchestration to start runners on the minions that you need to configure. For example, if you need to configure minions in a specific order, you could send commands to run runners in these minions. Okay, so let's talk about pillars. Pillars, they are basically variables or data configuration associated with a minion. They are mostly used for configuration, but I believe the motivation to develop them was to store secrets. And so they are encrypted, and they are only sent to the minions they're associated with. So they are very secure, and they're very useful for transferring secrets and configuring minions because it never leaves this environment between the master and the minion. They are usually configured through the top state file on the master, but they can also be stored on external resources like a database. So in this case, when they are stored externally, they are called external pillars, and they need special modules to access them. For example, you have the MySQL external pillar and the Postgres external pillar. There's also a module called SQL base that can use to extend and implement your own module for a particular external source for pillars using SQL. Okay, so now that you're hopefully familiar with these three concepts, they're very important. Let's go over our implementation. The requirements we have from Via Varejo, our clients, is we need to start firewall policies in a Oracle database, and that needs to be replicated in the firewall devices, the FortiGate devices. We also need to be able to access the FortiGate firewalls to configure them. We need to automate the entire process so that new minions joining the environment, and whenever a minion changes their profile, it's propagated to the firewalls, reconfigured in the firewalls, and also in the database, of course. We need to be able to change these firewall policies in the database because things need to be changed due to jurisdictions or new servers entered in the environment. So we need to be able to change these firewall policies. Also, we need to be able to do this through the change management tool. So our client Via Varejo is using ServiceNow, an ITSM tool to do change management. And we also need to keep all firewalls in sync with the policies in the database. There can never be too much of a window of divergence between these configurations. Okay, so we are using an Oracle database to store everything. This was not a deliberate choice. This was actually a requirement from our client because they are using an Oracle database hosted in their environment. And to access their Oracle database, we are using an open source Python module. It's called CX Oracle. It's maintained by Oracle themselves, and it's really good. We also built an external pillar module for Oracle because I wasn't able to find one already made by Salt or anyone. So Salt has a module to access Oracle, but not for external pillars, I believe. So we developed one and use the external pillar to read the current profile of a minion from the database, among the other things like network info. And this pillar will be important later to start the current profile of the minion. So in this database, we also store the data for all retail stores, and they are associated with FortiGate firewall. So like the IP of the FortiGate firewall, the physical address of the store, and credentials to access the FortiGate firewalls. We also store minion profiles with some network data, such as their IP and MAC addresses. And finally, we store everything that we need to represent the FortiGate firewall policies as objects in the database. These are addresses, address groups, services, service groups, and policies. So we store everything that we need to manage on the database. And here's a layout of this environment. So we have the Salt master, which has access to an Oracle database and the FortiGate firewalls. And all the minions are running under these FortiGate firewalls. Notice how the minions don't have access to the database. Everything is done by the master. And to access these FortiGate firewalls, we are using an open source Python module. It's called PyForti API. I wasn't able to verify this, but I believe it's not maintained by Fortinet themselves. So I shout out to James Simpson for this wonderful library. And on top of PyForti API, we also built a wrapper to adapt it to our implementation. So it basically just renders error codes and some specific conditions that we needed to consider. Okay, so let's talk about solving the main issue faced by our client via Varejo. So it's basically automating the firewall configuration for minions changing profiles and new minions joining the system. So we saw that your minions can have different profiles. So we have a custom grain that we made to store the profile the minion should have. This grain is generated using data from a file. And if this value from the grain doesn't match the profile that the minion currently has, which comes from the pillar, that's why I said it's important. If this two doesn't match, an event is fired on the event bus containing some network data and the store the minion belongs to, and the new profile the minion should have. And then Reactor picks up this event from the event bus and starts up some orchestrations. These orchestrations are responsible for inserting the new data that came with the event into the database, so updating it into the database, as well as adding the minion's address to the correct address group in the Fortinet firewall associated with the store. And this orchestration also creates any policies, services, or other groups, etc., that might be missing from the firewall. This happens, for example, when the minion is the first one joining a profile, so the objects aren't already created in the database. So this orchestration is also responsible for creating that. And every time a new minion is introduced into the system or changes profiles, we use the reactor system to escalate the event to the master in order to fire up this orchestration. That's basically the flow of the system. There are two ways to change a minion's profile. As I mentioned before, we only need to change grains to store which profile a minion should have. So whenever a high state runs, it will check if the profile changed and fire the new profile event if needed. A more streamlined way to do this is by using a bash script we developed. It has a graphical interface to select the new profile, and then it runs the necessary steps to change the grains, install the new profile, and fire the event. This is usually done by a technician when setting up the minion. So here's basically how this process works. And think of this as a timeline going from left to right. So first, a technician runs the bash script to select the new profile, which calls the state responsible for gathering the network data, store, and etc., and firing up the new profile event to the event bus. This can also happen during a high state if the profile grain was changed through other means. Someone changed the file or something, and then it also calls the same state. So once the event is published to the event bus, it's picked up by the reactor, and then it escalates the execution to the master. So everything is running on the master environment now. And then the reactor fires up two orchestrations. One of them used to update the minion data in the database, and the other is used to configure the FortiGate firewalls. After the event is fired, everything happens here. So minions have nothing to do with it anymore. And also note that the credentials never leave the orchestration. That's really nice. So here's some screenshots of the bash script I was talking about. Basically, just a bash script with some dialogues. You can select the profile, and then it runs all the steps to register the minion on the master. The important thing to take from these screens are the three commands it runs. So the first one, it changes the file that's used for the custom grain, and also clears some cache and make sure the grains change to match the new profile to what the new profile should be. And then the second one performs any installation we all actually use two installation steps. This is the fast change install. It installs some basic things that need to be changed to match the new profile. And then a second install is used on a high state to install any software required by the new profile. The third command executes the state that is responsible for gathering the network data and firing the profile event. So this is the state that changes the profile file. It's pretty straightforward. So just a file managed, changing the contents of the file. Pretty simple. Sorry. And this is the state that actually fires the event. All the data here is taken from grains, from custom grains, and the current profile is taken from pillar, the external pillar, and the profile is taken from the grains. The current the profile that it should have is taken from the grains. This is the reactor configuration, so you need to configure this on the master. It's basically just telling whenever this event is fired, run this state. Is basically what's happening here. And this is the reactor state itself. Its job is just running an orchestration, running this orchestration, and passing along any data from the event. And finally, these are the two orchestrations that run. The first one is used to update the minion data in the database, and the second one is used to add the minion to the correct policies in the correct firewall associated with the store that's associated with the minion. As I said, it also takes care of removing it from its previous policy and creating any new objects in the firewall as needed if they're not already present. I won't be going over the code for this two because it's pretty extensive, but there will be a link at the end of this presentation where you can check out the full code for our solution if you're interested. Okay, so the second challenge is basically we need to be able to change firewall policies. That was another requirement from our client, Via Varejo. And also these changes need to be approved by a change management tool. So they're, like I said, using ServiceNow for that. And to help ServiceNow communicate with Salt and to be able to change firewall objects in the database, we built a simple REST API using Flask just to use the communication between these 2 points. This is what the layout looks like for this system for changing policies. First, the change must be created and approved. It's created through some forms in ServiceNow, and it needs to be approved by administration in ServiceNow. ServiceNow then makes a request to an endpoint in the Flask API to change the database. So Flask applies the changes to the database, and then it runs an orchestration on the master, asking it to apply the changes to any affected firewalls, by any firewalls affected by that change. Here are some simple forms taken from ServiceNow. So it's in Portuguese, but it's basically just some forms to change firewall roles, and then it can be ordered, and then it needs to be approved by an administrator, and then once that's done, Flask does everything else. ServiceNow just needs to call some endpoints on ServiceNow. And the third challenge was making sure that the FortiGates are all synced. So to guarantee that all changes are applied to the affected firewalls and to keep them in sync with the objects in the database. We are using a cron job for that. It periodically requests this update from the Flask API. And the Flask API then accesses the Salt master and runs an orchestration that checks all the firewalls with pending changes and compares them with the data in the database. It generates a patch and applies the patch to all firewalls so they always remain in sync with the database. We are using Salt Pepper in the Flask API. It's a Python module made by SaltStack to access Salt through the Salt API. This is the layout for the syncing. It guarantees that the firewalls remain sync. So we have the cron job, which requests the updates to our Flask API, which then lists all the firewalls with pending changes and runs the orchestration in the master. The master then compares each firewall with the database and applies the patch to each firewall as needed. So with these three systems, we successfully provided and deployed an alternative to solve our clients' issues. And now Salt is able to automatically configure all of their thousands of FortiGate firewalls integrated with ServiceNow for change management. So here are some points that we could improve in the future. And we also welcome everyone, anyone that wants to contribute to make changes. So first, there's nothing wrong with cron tab, but I believe a more elegant solution would be to replace the cron jobs with a systemd service. We also could extend the set of features we support from the Fortinet API. It has a bunch of features. We are only implementing what was required by our client, but there's a lot of room of improvement here. There's a lot of features in the Fortinet API that could be used. Also, since our client is using Oracle database, that's what we implemented. We didn't bother to implement support for other databases because it would be used by them. But obviously, that's another major candidate for improvement in the future. And with that, we conclude our implementation using Salt and the concepts it brings to the table to automate the configuration of thousands of firewalls for Via Varejo. If you're interested, here are some useful links that you might want to check out. SaltStack.com, of course, if you're here in SaltConf, you probably already know about it. But go check them out, they're awesome. And if you want to see more about our work, check us out at sys.com.br. If you have any questions about this project or something in the future, feel free to contact us through these emails. You can also see more about Fortinet.com. And also the libraries that made this project possible are at these GitHub repositories. So have PyForti API and CX Oracle. We also published all the code for this solution in GitHub, along with the code for the Oracle external pillar module that we developed. So if you're interested in that, both are open source, so feel free to use them, study them. We also encourage you to make changes to help us develop these solutions. The code that was published was a little bit simplified from the one that we deployed for our client, but mostly because of some very particular cases and consistent checks that we need to take into consideration. The core of it is out there, so feel free to check it out. And I hope you guys liked it, and thank you everyone for watching. We'll be open for questions now.
Well, first things first, I think we all need to give a bit of a round of applause to both Felipe and Lucas. You guys did a fantastic job. Bravo. Well done, gents.
Thank you.
Really, really good. Really good. Yeah, now would be a great time for questions. I noticed that Rodrigo, you have requested to share your audio and video. Rodrigo, do you still have a question? Why don't you go ahead and post in the chat? I'm going to go ahead and turn you on here. See if Rodrigo's still there. Looks like he may not be there anymore. Okay. So we have a question from Gabriel, gentlemen. He says, how easy is it to switch the service? How easy is it to switch the service now to other solutions, Zendesk, for example?
It's really quite easy because we are using the Flask API to provide everything under the covers. So if you need to change to another solution, you just need to implement the calls to the endpoints. The data is all going through the Flask API, so it's really easy to change.
All right, excellent. Any other questions? Now would be the time if anybody has questions for either Felipe or Lucas or both. No? Oh, hold on one second. That could be my fault. It is my fault. Rodolfo, thank you very much for telling me. Is that better? I had it hanging down to the side there.
That's
Much
good.
better. Okay, I apologize to all of you. I thought the mic was on the other
That's
side.
okay. We could hear you before.
You can still hear me. Okay.
Yeah, that's fine.
Great. Leave it to the moderator to screw everything up. I'm so sorry, guys.
Thank
Okay.
you for moderating our session, by the way.
Oh, well, you're very welcome. So does anyone have any other questions? No? Speak now, forever hold your peace. Is that going to be it? Once again, a reminder for you, we have recorded all of these sessions and we will make them available in the next day or so to all of our SaltConf attendees. So thanks to each and every, oh, wait, hold on. One more here, Gabriel, before we leave here. He says, how about use another database other than Oracle?
That's a bit more complicated because Oracle database was integrated into the implementation. So to use another database, you would need to rewrite some of the code. It's not that hard, but we need to take in consideration that Oracle is kind of an integral part, and then you would need to modularize the solution to use another databases. We are using a module, a separated module to call everything that you need from Oracle. So mostly it would be rewriting this module to be able to access other databases, but you need to implement the calls and connections and everything.
Okay, hopefully that answered your question, Gabriel. Do we have any others? No, that's it. All right, you're welcome, Gabriel. Hey, once again, I'd like to invite all of you to check out SSYS, check out Felipe and Lucas's company for IT consulting, and send them any emails with further questions that you may have about what you saw here in this presentation. Again, big congratulations to both of you. Knowing that English is not your first language, I thought you both did a fantastic job. So well done. Well done.
Thanks.
Great work. All right, we'll give you guys a little bit of extra time before you head off to your next session to grab a snack or use the restroom or whatever you need to do. And we'll see you at a 1:15 for the next session. Thanks, guys. Well done.
Thank you.
Thank you. Bye-bye.
Hope you guys like it.